average rate of change. So we can think about average rate of change as a change in the function value divided by the change in the x value. These triangle looking symbols, they're called deltas, and they mean change. So it's the change in the function value divided by the change in the x value. And this change in the x value is, when we divide by it, it's what makes it an average. Okay. The top is sort of the absolute change that the book talks about, and when we divide by the change in the x, that is what makes it an average. So let's do an example. Let's take f of x equals x squared plus 3x plus 1, and let's compute the average rate of change from x equals -4 to x equals 0. So in order to do this, we're going to compute the change in the function value divided by the change in the x value. So that is f of 0 minus f of -4 divided by 0 minus -4. Something I want you to really take a look at is the 0 and f of 0. They are lining up in this fraction. Likewise, the f of -4 and the -4 are lining up in this fraction. Okay. So let's compute each of these. We're actually going to evaluate f at 0. So if you look in the function, f of 0 should be 0 squared plus 3 times 0 plus 1, which should give us 1. And f of -4 should be -4 squared, which is 16, plus 3 times -4, which is -12, plus 1, and that should give us 5. So we get 1 minus 5 divided by 4. That denominator simplifies to 4, and we get -1. So our average rate of change from -4 to 0 is -1. All right. So we want to also know, what does this mean graphically? So we're so busy about talking also about what functions look like in terms of the graph. We want to know, what does this mean graphically? So let's go ahead and graph our function. Here it is, y equals x squared plus 3x plus 1. And so let's think about, what is it when x equals -4? When x equals -4, I have this point right here. Oh, this point right here. If it'll let me do it. There we go. We have that point right there. And the way we get that point is that we evaluate f at -4, and out comes 5. That's what that 5 means. So right here is the point -4, 5. It's what we get when we evaluate f at -4. And then likewise, this point right here is what we get when we evaluate f at 0. So we get f of 0 is 1. So we have the point 0, 1. So the points on the graph are actually, the y values are what we get when we evaluate the function. If we go back and, well, let's go ahead and see what that looks like. There are my 2 points. Okay. So if we go back and we look at this calculation we did, this calculation feels a whole lot like slope. And it is a slope. That numerator, that's a difference in y values. And the denominator is a difference in x values. So if we go back to our graph, I have these 2 points, and I'm finding the difference in the y values divided by the difference in the x values, which is the slope. And it's actually the slope of the line that goes through those 2 points. So we can think of the average rate of change, or average rate of change, is the slope of the line through those 2 points. And the line through those 2 points is called a secant line. It's a slope of a secant line. So we're going to keep talking about slopes of lines and how they relate to functions. Starting from now, we're going to be covering a lot of calculus, and calculus is all about changing and how to measure a change. So we're starting out by talking about average rates of change and we're measuring how something changes over an interval of time.